Welcome back, students. Today is the Q&A session 23 from the playlist of JEE Physics, and the chapter is current electricity. The question for this session is written on this board. The question is: an EMF source of 10 volts is connected to a variable resistance. The internal resistance of EMF source is negligible. Resistance varies as shown in this figure. The figure is here. This was a figure which was provided in this question, and so this is T1, which is equal to 10 seconds, and this is T2, which is equal to 30 seconds. At T1 equal to 10 seconds, the resistance is 20 ohm, and at T2, which is equal to 30 seconds, the resistance is equal to 40 ohm. And so this is the diagram which was given along with this question. The resistance varies as shown in this figure. The total charge that has passed through the resistor R during time interval T1 and T2 is. These are the four options which are given here, and we have to find the correct one. So, in order to explain this question, I will be taking the help of a Cartesian frame of reference, which will be an XY plane, and here I am drawing one line, which it's a straight line, and the equation of a straight line, as we have learned in the coordinate geometry, is y is equal to mx plus c. The equation of a straight line lying in this xy plane is equal to y is equal to mx plus c, where y and x are the coordinates of any point which is lying on this line. X and y are the coordinates of any point which is lying on this line. M is the slope of the line. This M is the slope of the line, and c is a constant. So I will be now taking this reference in order to derive the relationship between R and T. So if I substitute y with R, I will get R is equal to, I will substitute this x with T. So I will be getting R is equal to M T plus C. What I have done is I have substituted this y with R and x with T. So I have got one equation which is R is equal to MT plus C. Now from this figure you can see that at T1 is equal to 10 seconds, the resistance is 20 ohms, and at T2 is equal to 30 seconds, the resistance is 40 ohms. So R is equal to 20 ohms at 10 seconds, so that is equal to 10 into M. This is the equation number 1, and the resistance is 40 ohms at T is equal to 30 seconds, so 30 M plus C. This is the equation number 2. Now it implies that 30 M plus C minus 10 M plus C will be equal to 40 minus 20. So it implies that C will get cancelled out, and I will be getting as 20 M is equal to 20, or M is equal to 1. Now I will be substituting this value of M is equal to 1 in the equation number 1. So what I will be getting is 20 is equal to M is 1, so that is equal to 10 plus C, or C is equal to 10. So if I put these values, M is equal to 1 and C is equal to 10 in this equation, that is R is equal to MT plus C. So I will be getting the equation as R is equal to T plus 10. So this is the relationship between R and T. So R is equal to T plus 10. Now this resistance is connected to an external EMF source of 10 volts. So So current through that resistor will be equal to 10 divided by the value of R, which is equal to 10 plus T plus 10, and this is equal to I is also equal to dq upon dt. Or we can say that it implies that dq is equal to uh, 10 divided by t plus 10 dt. Now we have to find the total charge that has passed through the resistor during the time interval t1 and t2. So if I integrate this equation, that is dq is equal to, limits will be from 10 to 30, because we have to find the total charge which has passed through the resistor during the time interval t1 and t2. So our limits will be 10 to 30, that is t1 is equal to 10 seconds and t2 is equal to 30 seconds, and this will be equal to like this dt. So finally we have got this equation, and by solving this equation we will be able to get the total charge which has passed through the resistor between time t1 and t2. So it implies that q will be equal to 10 is a constant, so I will be taking it out here, and I will be getting as 10 30 1 divided by t plus 10 dt. So it implies that now what here I will do is I will substitute. Now we first of all we know that integration of 1 by x dx is equal to log x to the base e. So I will be using this formula in order to solve this equation. So but here first of all I will be doing, I will be substituting this t plus 10 is equal to say u. So du upon dt will be equal to 1, or we can say that du is equal to dt. So 10 integration from 10 to 30, this will be equal to 1 by u du, because I have substituted the this dt is equal to du, so I have substituted the value of dt as du. So it implies that q is equal to 10. This will be equal to log u to the base e. Log u to the base e, and we have to integrate it from 10 to 30. Now u was equal to, we have taken as t was equal to u plus 10. So I will be substituting the value of u as t plus 10. So q is equal to 10 log e t plus 10 from 10 to 30. So it implies that q is equal to 10 log e. Now I will be substituting the value of t as 30. So it will be equal to log 40 to the base e minus log 20 to the base e and it implies that q is equal to 10. This will be equal to log 40 of 120 to the base e, because we know that log a upon b to the base e is equal to log a to the base e minus log b to the base e. So I have used this formula in order to solve this equation. So Q is equal to 10 log 40 divided by 20 to the base E. So now it implies that Q is equal to 10. This will be equal to log 2 to the base E. So the total amount of charge which has passed through this resistor between the time interval T1 and T2 is equal to 10 log 2 to the base E, and here our answer is the correct option is B. The option B is 10 log 2 to the base E. So our correct option is B. So now in this question, the most important thing which you need to understand is that here you have to first of all find the relationship between R and T by using this concept of the line equation which we use in the coordinate geometry. In the coordinate geometry, the equation of line is given by y is equal to mx plus c, and this is the equation of a straight line, and y is equal to mx plus c is the equation of the straight line which is lying in the xy plane. So using this reference, I was able to derive the relationship between R and T, that is R is the resistance and T. What I did was that I had substituted y with R and x with T. So I got R was equal to m T plus C, and then we were given here the value of the resistance at time T1 and the value of resistance at time T2. So using these two datas, I was able to find the value of M and C, and thereafter the equation which we got was R is equal to T plus 10. So that was this was the most important thing in solving this question. So the correct option is B, that is the total charge which has passed through the resistor R during this time interval T1 and T2 is equal to 10 log 2 to the base E. So thank you very much for joining this session, and in the next session I will be coming up with some different type of a question. So till then, have a nice day. Bye.